Good day, Algebra. We are learning a little bit of science today, where science and math meet together. Did you know, and I'll be honest, I had to look this up before class today, but did you know the Earth is 492,750,000,000 feet from the sun? It changes periodically, so right now, it's this far away, approximately. Write that number again. 400. Well, then this isn't accurate. 492,750,000,000. Let's write it again. 492,750,000,000. Making sure y'all are writing it down so you really appreciate. What's that? That's what I said. Didn't I say that? Well, it's 492,750,000,000 is how you read that number. Okay. What if you're writing an essay? You might have to write 492,750,000,000 a dozen times. But you don't have to, because we have what's called scientific notation. Has anyone worked with scientific notation before? What is it, Tristan? Well, it's not so much a formula. It's more of a notation. It's a way to write something, because that's what the word notation means, a way to write something. Chase, Will, it is a way to write numbers, and I should say really big or really small numbers using powers of 10. So we're kind of getting into exponents a bit today as well. Scientific notation is a way to write really big or really small numbers. Would help if I wrote the words. Really small numbers using powers of 10. Because if you think about it, in science, you work with really large numbers a lot, especially if you're working with space. If you're working with molecules, cells, you write really small numbers a lot, okay? And so that we don't have to write this much, we have powers of 10 to help us. Everyone good with the notes? Drop down? No? Finish up? Or watch the video and don't forget to like and subscribe, okay? So the goal of scientific notation is to move the decimal point left or right until there's only one non-zero digit before the decimal. Let's do a few together. And actually, we're going to start with the number that we wrote up above earlier, 492,750,000,000. Okay? Where's the decimal point right now with this number here? Colin? It's at the end, right? If there's no decimal point written, it's understood that it's at the very end. Okay? And the reason why using powers of 10, when you multiply something by 10 or you divide something by 10, what's really happening? What is multiplying or dividing by 10 cause to yeah, Ryan? It moves the decimal point forward or backward. That's why whenever you multiply by 10, you just add a 0 on there. Because all you're doing is you're shifting the decimal over to the right, and you're replacing that new place value with a 0. So to get my decimal point where I want it to be, which according to the key point up above, it says there's only one non-zero digit before the decimal, I'm just going to start hopping. And I have to move it I wrote that number wrong, didn't I? Why didn't someone say anything? You were just waiting for me to... No, it actually is important to write numbers correctly in mathematics. Believe it or not, it does make a difference. Okay? I have to move my point all the way over so it's just after the 4. Because, again, in our definition up here, it says only one non-zero digit before the decimal. Right? So my non-zero digit there is a 4. And how many times did I move that point? a lot, more specifically, 11. And here's where commas can be helpful. Every comma is a jump of 3, right? So 3, 6, 9, 10, 11. So I move the decimal 11 times. Okay? So here's how I would write this number using scientific notation now. I've got my 4 and my point, because I moved the point there. And then every non-zero digit gets included. So the 9, the 2, the 7, and the 5. Okay? Not times 11, times 10 to the 11th. Why times 10 to the 11th? Maddie. Shh. Oh, Maddie's got the floor.
10 to the 11th power would be that number right there, and then so you're just moving the decimal back to the end.
Right. 10 to the 11th power means I'm multiplying by 10 11 times. And every time I multiply by 10, that decimal point gets kicked over to the right. So to get back to my original number, I would have to move the decimal to the right 11 times. Showing that using powers of 10, that's 10 to the 11th power. Okay? So 4.9275 times 10 to the 11th would be scientific notation for that number. In your calculators, you know how kids sometimes like to just see, what's the biggest number I can make in my calculator? And you get that that thing up in the corner where it's like times or e to the whatever or times 10 to the whatever. That's scientific notation there. Okay? Your number's so big that your calculator tells you how many digits are in it using scientific notation. All right? Let's look at the examples here. 5,670,000. My decimal point right now is at the end, and I want to move it so there's only one non-zero digit before it. So 1, 2, 3, 4, 5, 6 times, right? I had to move it 6 times to get it after the 5, because I only want one non-zero digit before it. So in scientific notation, all those zeros drop off, and I've got 5.67 times what? Eli? 10 to the 6th. Okay? Times 10 to the 6th. And scientific notation is really the only place in algebra where you'll see the x referred to as multiplying. Once you kind of get to algebra, then we use the dot, we use parentheses because x is so often a variable. Scientific notation is the one place where you'll see me use the x to show that we are multiplying, because that's what the notation says. Okay? But it's how many times you have to move that decimal. Like I said, commas can be helpful. So when you've got a number such as 878 trillion, you can just move in jumps of 3, right? 3, 6, 9, 12, and then 2 hops for a total of 14 times to get it in between the 8 and the 7. Because remember, we only want that one non-zero digit before the point. Okay? So 8.78 times 10 to the 14th. Now, in these two examples, and really the first 3 examples, notice how our power is positive. Why is that? Why is our exponent positive here? Maybe it might not make sense till we do the other two, because if you notice, these are a little bit different. Okay, let's actually do these first here. All right, let's do these first before we answer that. Now, in this case, 0.00013, we see the decimal point, right? This is a number that's very small. It's less than a whole, a lot less than a whole. But we still want to move that decimal so there's only one non-zero digit before it. So which direction are we going to move the decimal point now? Nick? To the right. And we're going to move it 1, 2, 3, 4 times. Okay? So it's between the 1 and the 3. So our scientific notation is going to start, like the other ones did, with a 1.3. But how are we going to show, spoiler alert, how are we going to show that the number we're starting with is actually really small? Sam? The exponent's going to be negative. Okay? You'll learn about this very soon when we cover negative powers. You haven't really talked about them yet. But a negative exponent kind of means division in a way. So this is going to be 1.3 times 10 to the negative fourth. And what that negative fourth tells you is that you're going to be dividing by 10 4 times. Because when you divide by 10, you're essentially moving that decimal over to the left. If you've got something like, 860 divided by 10, what is the answer? 86. You move the decimal over to the left, right? That's what negative powers do. It's what dividing by 10 does. So if your number is really small, your exponent is going to be negative. The next one here. Unfortunately, there are no commas with really small numbers, so we have to actually move and count. But 1, 2, 3, 4, 5, 6, 7. We moved it 7 times to get the 4.901. Because that 4.901, because that 0 is in between two non-zero numbers, we have to include it. Okay, we wouldn't leave that 0 out. But what would the rest of this be? 4.901, Colin? Times 10 to the negative 7th. And that negative 7 tells us you go left to get your original number. So why is the exponent positive? Why is the exponent negative? What do those exponents tell us, Paul?
The exponent is positive because the decimal starts. Because the decimal starts like at the zeros.
It starts at the end of the number? No? Well, when our exponent's positive, our decimal did start at the end.
It's on the left side.
What's that?
On the left side. Not on the right side of the decimal.
The decimal starts here.
Yeah.
Right? So it's on the right side. We move it to the left.
So, yeah.
Okay? So the exponent's positive because we are multiplying. Multiply spelled M-U, not M-O. Multiplying. We are multiplying by 10. And our original number is big. Okay? The exponent being positive tells you that the original number is really big. You're multiplying it by 10. You're moving to the right to get back to the original number. Okay? When our exponent's negative, it means that we are dividing by 10. And your original number is very small. Okay? Questions on this thus far? Professor Olson will be very pleased that you know how to do this once you start dealing with these types of values, right? To go from scientific notation to the original, 7.613 times 10 to the fourth, we have a positive power, which means which direction do we move to get back to our original number? Left or right?
Right.
We go to the right, right? And we go 4 times. So 7.613, we're going to multiply by 10 or move it to the right 4 times. 1, 2, 3, 4. What do we fill in that now empty spot with, Maddie? A 0. So our original number was 76,130. Okay? 6.8 times 10 to the 10th. Again, a positive power. We're moving it to the right. We're multiplying by 10 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All those now empty spaces get filled with zeros. I once had a student like to put smiley faces on them because they were like there were people floating in the ocean. You do you, whatever, okay? But our original number, we can add some commas in here every third. 68 billion, it was our original number. Okay. I'm going to erase that to do the next one, so get caught up with the notes there. Everyone good?
Yeah.
Okay. The next one, our exponent's negative, which means we're going to the left. Our number is very small. We start with 5.1973, and we're going to the left 7 spots. So 1, 2, 3, 4, 5, 6, 7. All these spaces get filled in with zeros, including our spot before the decimal, to show we have 0 holes, to show it's a very small number. So that would be our original number, something very, very small. Since you're probably out of space now on your page, I made the last one very short. You only move it twice to the left. Boop, boop. And we get 0.0821. Again, very small. Okay. So your homework for tomorrow, another chance for the number game. The first section, you are converting from standard form to scientific notation. So it's what we started doing up the top of the front side. The second part, you're rewriting from scientific notation into standard form, the bottom half of that first page there. And then at the time of this document's last edit, I was about 1.2 times 10 to the 9th seconds old. How many days is that? Notice I'm giving you the value in seconds. So you have to convert that to standard form. That tells you how many seconds old I am. You're converting that to days. Don't forget about the conversion to days. And then review here. You've got some things from CO1, CO2, PO3, and then CO4 as well. Okay, so the entirety of this page due for tomorrow. Any questions from you? In the spirit of Christmas, I've left you 2 minutes of quality work time. Take advantage. That's how you math.